Hey, welcome to Solving Equations with Rational Exponents. What we're going to do in this is we're going to take some equations that have rational exponents. That means they have fractions in their exponents. And we are going to solve them, and then we're going to determine if any of their solutions are extraneous. So we have a few steps to solve. First, we have to isolate our variable expression. And then we're going to reciprocal power on both sides. That means you flip over the exponent. So if you have a fraction like 2/3, that's going to flip over and become 3/2. And then the last thing we're going to do is, well, solve for the variable since they are equations. Now, I have a little helpful hint here. You know that x squared, when it's equal to 9, that x is going to be plus 3 and minus 3. Why is that? Because positive 3 times positive 3 is positive 9, and negative 3 times negative 3 is also positive 9, because a negative times a negative is a positive. That's why you get two answers on these. Now, what does that have to do with what we're doing today? Anytime you take an even power root, that's like square roots, fourth root, sixth root, you'll have to add a plus and minus. So our first example, we have 3 times x plus 1 to the 3/5 equals 24. So remember when we first started doing any equation solving, I said you always look for the weird stuff. That's what you're isolating. Well, I'm going to say this is the weird stuff, the stuff with the 3/5 exponent. And it's not isolated because it has a 3 in front of it. So I'm going to divide both sides by 3. This is me isolating. And I now have x plus 1 to the 3/5 equals 24 divided by 3 is 8. So I just took care of step 1. Step 2 is you flip that exponent on both sides. So over here, I'm going to put to the 5/3, and same thing over here. That's the reciprocal power. Now, why do I do that? Well, the reason why is because right here, where I circled, those guys cancel each other out. Since they do, I get what's down here, which is x plus 1 equals to 8 to the 5/3. Now this is where I can go to the calculator. In my calculator, I can type in 8 to the 5/3. And when I do, it's going to do the cube root of 8, which is 2, and 2 to the 5th is 32. So it's going to tell me that 8 to the 5/3 is 32. So I'm going to replace x plus 1 over here. This 8 to the 5/3, I'm going to replace that with 32. And then I check to see, is my x all by himself? No, he's got a 1 over there. So I'm going to subtract 1 from both sides. And my answer is 31. Now, when I do this, I should do a check on mine to see if I have anything that's extraneous. So I'm going to do a little bit of check. And remember, the way you check things is you plug your number, which was 31, back into your original equation where the x was. Well, I drew him to the wrong spot, so hold on a minute. For 31, back into your original equation where the x was. So 3, and then inside was 31 plus 1 to the 3/5, and I want to know, does that equal 24? And this is 31 plus 1 is 32. to the 3/5, does that equal 24? And if you put 32 to the 3/5 in your calculator, that's going to give you 8. So 3 times 8, it does equal 24. So this guy checks. He is not extraneous. This check you should perform, and you can do it mentally if you want. You don't have to write this down. I just want to make sure you know how to do it. Let's try some more of these rational exponent equations. This one's beautiful. X plus 1 to the 4/5 equals 16. So the first thing I'm going to do is I'm going to check to see if I have any weird stuff, which I do. That's this guy here. X plus 1 to the 4/5. And is he isolated? Yeah, that's all by himself over on the equal sign. So isolating's done. So the next thing I do is I write my problem down. And I'm going to do the reciprocal power on both sides. So 4/5 flips over and becomes 5/4. And remember, there's a reason why we do that. 4/5 and 5/4, the guys that are flipped over from each other, multiply to make 1. So then I get what's underneath, which is x plus 1. And that equals 16 to the 5/4. And then I go to my calculator. I type in 16 to the 5/4. And the calculator is going to tell me the answer is 32. Because the 4th root of 16 is 2. And 2 to the 5th is 32. Now, I do caution you at this point, the calculator is not very smart. Notice this denominator, 4th, is an even number. Since that's an even bottom number, I'm not going to just get 32. I'm going to get x plus 1 is equal to 32. And I'm going to get x plus 1 is equal to negative 32. Anytime you have an even number, you get plus and minus. So I get positive and negative 32. From there, I just solve for x, both of those. So minus 1 on both sides. I get one answer is 31. And I get one answer is negative 33. Then I perform my check. So those guys are going to go back into my original equation where the x is. So on my check, I do 31 plus 1 to the 4/5, and does he equal 16? That's 32 to the 4/5. Does he equal 16? Well, the 5th root of 32 is 2. 2 to the 4th is 16. So this answer is yes. 16 does equal 16. So yes. Now check the other one. So I'm going to put negative 33 plus 1 to the 4/5 and see if that equals 16. Negative 33 plus 1 is negative 32 to the 4/5. Does he equal 16? The 5th root of negative 32 is negative 2. And negative 2 to the 4th power is, believe it or not, positive 16. So yeah, he checks. So those are good answers. Again, the check you don't have to write down. You can do that in your calculator or in your head. But I do want you to know that if we didn't check, it would be extraneous. All right, let's try another. All right, we want to solve this rational exponent equation. So remember, our first thing we need to do is check to see if the weird thing, the thing with this fraction exponent, is isolated. He's not. He's got a 3 over here, so I'm going to subtract 3 to both sides, and I get 4 minus x to the 3/2 equals 8. Now it's isolated, so I'm going to do the reciprocal power. 3/2 flipped over is 2/3. Remember, we do this on purpose because 3/2 and 2/3 will cancel, and you'll get what's underneath, which is 4 minus x. And then you go to your calculator, 8 to the 2/3, and it should tell you that that is 4. Cube root of 8 is 2, 2 squared is 4. And since 3 down there on the bottom is an odd number, I don't have to worry about any plus or minuses. So I've got 4 minus x equals 4. And then I solve for x. I want to move minus 4 over to get the x by himself. So I get negative x equals 0. Divide by the number in front of x, which is negative 1. So x is 0. And then I should do my check. When I plug 0 back in, 4 minus 0 is 4. 4 to the 3/2. Well, the square root of 4 is 2. 2 cubed is 8. 8 plus 3 is 11. He checks.